Hello and welcome to Special Factorizations and Factoring where a is greater than 1, Part 3, where we're going to be looking at factoring where a is greater than 1. Okay, so what would make a greater than 1, and what do I mean by a? We'll recall from our last lecture video that we're working with things that look like this, but in our last lecture video over factoring, this guy was always just x squared, or 1 times x squared, right? There's always that phantom 1. And so what does it mean when a is not 1? Well, that means it's not just going to be x and x, it's going to be something times x and something times x that gave us that term. So I want us to look at something times x plus a number times something times x plus a number. Remember, this a, c, b, and d, they're all just numbers. We just use what we call variables to represent those, or really constants to represent those numbers. So let's multiply these guys out. We're going to do ax times bx, ax times d, c times bx, c times d. Let's write it out. Okay, and then now let's simplify that. So ax times bx, well, whatever a and b are, we're going to multiply them, right? Remember, they're just numbers, so that could be like 2x times 3x. So what would you do? 2 times 3 is 6, and then you would do x times x. So just like you would just do 2 times 3, we're going to do a times b. And then we're going to have an x squared there, right? Here, we can rewrite these guys. So I like c times bx because that's just a number times x, right? This guy looks a little weird though, so I'm going to rewrite it. I know I can multiply things in whatever order I want to. That's one of our properties of equality. So I'm going to rewrite that as a times d times x, and then keep it as c times b times x, and then c times d. And then notice this middle term. What would you do here? Remember, this is just like a 2x, right? Plus a 3x. What would you do? You would do 2 plus 3 is 5, and you would say that's 5x. Well, this is a times dx, this is c times bx, so what are you going to do there? You're going to do a times d plus b times c, or c times b. You can leave it that way, or you can move them. I like alphabetical order, so I changed them up. And so what does this multiply out to give me? A times bx squared plus a times d plus b times cx plus c times d. Which means if I'm taking something like this, which is really just this with a little bit more complicated looking things in there, right? But our number, our x term, our x squared term must have come from something like this. So we're going to use this to factor quadratics where a is not just 1. So keep this in mind, okay? What ends up being connected to that x? This guy. What ends up being our number? This guy. What ends up being connected to our x squared? A times b. So when we have something like 3x squared minus 2x minus 8, okay, the first thing we're going to do is we're going to look for a common factor to pull out. There is no common factor between all the terms there. So then we say, okay, let's create 2 spots. We know this is going to come from something plus a number times something plus a numbers. And I'm going ahead and writing c and d here. Okay, but let's think about it. Before, when this was just an x squared, we said the only way for us to get an x squared if we were working with x and x, right? Well, that's still the case. The only way for us to get that x squared is if we're working with x and x. Now the question is, what are the ways we can get a 3? There's actually only one, 3x times 1x. So we know this guy has to factor into something like this. Okay, when we factor something, we are just rewriting it. So whatever this is equivalent to this guy. Well, let's figure out what this would be. And I'm not going to do this every single time. We'll start to recognize something, but I want to do it for this first guy. So we know the only way for us to get 3x squared is 3x plus a number, 1x plus a number. And then we don't know what those numbers are, but what would happen if we multiplied those guys out? Well, we would do 3x times 1x, 3x times d, c times 1x, c times d, and that would give us 3x squared. I'm not going to write out all the details like I did on the last guy. 3x squared plus 3 times dx plus c times 1x plus c times d. And again, notice these guys. That's just going to give me 3D plus CX, right? So now we're working with this guy right here. And we're saying that it is equivalent to this guy. Well, we have the 3x squared is 3x squared. But what does that tell me about this guy right here? Well, it has to be equivalent to this guy, which means that 3 times D plus C has to give me a -2. And then that deals with our 3x squared and our -2x. So then C times D must give me a -8. I'm actually going to write that right here. C times D should give me a -8. Okay, so now we need to figure out, okay, what are the D and C's that do this, that satisfy both of these guys? Well, there's a lot of different things that can add to give me a -2, right? Like 3 and -5. -400 and -398. Excuse me, +398, right? I could choose a bunch of different ways to give me a -2. So there's too many options for us to start here. So let's start here. There are very few things, or there is a finite number of things that multiply to give me -8. What are those things? Well, I like to start by writing out the factors of 8. We have 1, 2, 4, and 8. And then the negative means we could also have negative those factors, right? And then I'll just write for the other guy, right? Those are all my options for C. For D, I'll just write what has to be multiplied by 1 to get -8. Well, -8. What has to be multiplied by 2 to get -8? -4, -2, -1, +8, +4, +2, +1. So these are all our options for C and D. Well, now we need to figure out which one satisfies that. So we come over here and we say, okay, 3 times -8 plus 1 gives me a -24 plus 1 gives me a -23. That's not what we want. We want a -2. So that's not the combination we need. What about this guy? Well, that's 3 times -4 plus 2. That gives me a -12 plus 2. That gives me a -10. That still doesn't work. We want a -2. Will this combination work? Let's see. So we have 3 times -2 plus 4. That's a -6 plus 4. Oh, hey, that is -2. So our values must be 4 and -2. And the colors are very important here because C, representing what goes with the 3x, is 4, the blue number, right? D, representing what goes with the 1x, the purple, is -2. So this factors into 3x plus 4 and x plus a -2, which is 3x plus 4 times x minus 2. All right, let's do another one. Okay, so can we come to this 3-term quadratic? First, we look for common factors. 7, 22, and 3 do not have anything in common, so then we create our spaces, right? Now, the only thing, and it's really nice because what we've worked with in the previous guy, this guy's prime, which means the only thing that multiplies to give it is 3 and 1. And there's actually a lot of things that multiply to give us 3, but we're going to stick with whole numbers to make our lives easier. So what's the only thing that multiplies to give me 7y squared? Well, 7y and y. And then with some number. And then we're doing the exact same thing that we did on our last lecture video, right? We're saying, okay, what's going to happen here? Well, C times D is going to end up giving us our number, always, every single time. So C times D is going to give us 3. And we need to find the values that will give us 3. And then what else is going to happen here? Well, we're going to get a y term, right? The 7y and the y give me the 7y squared. The C and the D give me the 3, right? And then 7y times D is going to give me one of the y terms. And then C times y is going to give me the other y term, right? So 7y times D and cy is going to give us the y term. We want that y term to be connected to 22, which means we want 7 times d plus c, right? Because it's just c there, right? No coefficient. We want that to give us 22. So then we go and we do the same thing. Let's write out all the things that multiply to give us 3. That's 1, 3, -1, -3. And that could go with 3, 1, -3, or -1. All right, be very careful. Make sure you know your multiplication facts here. That needs to be a -3 with a -1. Okay, then let's see which one of these is going to satisfy the other, what else we need, which is that this adds to give us 22. So 7 times 3 plus 1 is 21 plus 1. Oh, hey, that's 22. We immediately found it. So C must be 1, D must be 3, so this will factor into 7y plus 1 times y plus 3. Okay, let's do one more example together that's a little bit more complicated. And then the hardest part about this is it's a lot to look at, especially when you're looking at it the first time. So it's going to take a lot of practice. But soon, when you practice it enough, it's going to be easy as you telling me that 12 is 4 times 3. You'll be able to tell me this factors into this, just like you can immediately tell me 12 factors into 4 times 3. But it's going to take a lot of practice. So make sure. Let's do another one. Let's look at this guy. So first things first, we want to pull out any common factors. These guys do have common factors. It has a common factor of 3 there. So we're going to pull out that 3. We're left with 8x squared plus 2x minus 3. Now this guy's a little bit different than the previous two guys. The previous two guys, what was connected to the x was prime. So there was only one option there. But there are actually 2 different options here. Okay. Either this can factor into 8x plus a number times x plus a number, or it's going to factor into 4x plus a number times 2x plus a number, which means there are multiple options on what we can get, how we can get 8x, right? We can either do 8x and x or 4x and 2x. Now, it's still going to be the case that our C times our D, whether we're working with this guy or this guy, the C times the D will always give us our constant term, which is not -9, it's -3 now. Okay, so we can go ahead and write over here, because this is the case for both of these scenarios, that C times D has to end up multiplying to give me a -3. So we write our options. We got 1, 3, -1, -3. -3, -1, 3, 1. Okay, but then 2 different things are going to happen here. In this case, we're going to have 8 times dx, right, plus c times x, which means in this case, we want 8 times d plus c to give us that 2. Okay, in this case over here, we want 4 times dx plus c times 2x to give us that 22. So, that 2. So we want 4 times d plus 2 times c to give us 2. Now, usually when these numbers are a little bit smaller and this number is really big, you're going to be looking at these guys right here first, or you're going to want to, because it's more likely that this factors into these smaller guys than these bigger guys, because these guys are smaller. So I'm going to actually start over here and see. Okay, so let's see. 4 times -3 plus 2 times 1. That gives us a -12 plus 2. That gives us a -10. That's not what we want. What about 4 times -1 plus 2 times 3? Let's see what that gives us. That gives me a -4 plus 6. Oh, hey, that gives me my 2. Okay, so what we're working with are these guys and these guys, which means this will factor into 4x plus 3 and 2x plus a negative 1, which is the same thing as 4x plus 3 times 2x minus 1. Okay, I said that was going to be the last one. Let's do one more together, okay? Let's look at this guy. So the first thing we see here, the first thing we always look for is that common factor. Now, 10, 17, and 3 don't have a common factor, but what else do we look for? This guy, we want this guy to be positive. It always makes our lives easier when that guy's positive. So let's go ahead and start here by pulling out a negative. That will leave us with 10n squared minus 17n plus 3. Now we want to factor that guy, so we're going to factor into something times something. And again, we end up in a scenario where there are multiple options to get that first term, that leading term. 10n and n could work, right? So this could factor into 10n plus a number times n plus a number. Or it could factor into 5n plus a number times n plus times 2n plus a number. Okay, because those are the options for multiplies to give me 10. So there's two options again here. Either way, again, this c times the d is going to end up giving us this 3. So either way here, we're looking where c times d is 3. Okay, which means our options are 1, 3, that's not a 3, 3, negative 1, negative 3. And that could go with 3, 1, negative 3, or negative 1. In this case, 10 times d plus c times 1, which is just c, that will give me my negative 17. In this case over here, it'll be 5 times d plus 2 times c should give us that negative 17. Okay, 10 is a pretty big number to work with. But so is 17. So really you can start in any position here. You just kind of have to guess and go with it. So let's just start with the 10 this time. So let's try 1 and 3. So we say 10 times 3 plus c, so plus 1. We want that to give me a negative 17. That won't work. In fact, neither of these positive values will work because positive times a positive, positive plus something is a positive. So there's no way to get 17 with these positive guys. So let's actually look at these negative guys. So we say 10 times negative 3 plus negative 1. Oh, that doesn't work. That's a negative 30 minus 1, negative 31. It won't work, okay? Last guy, 10 times negative 1 plus negative 3. That's a negative 10 minus 3. That's a negative 13. It won't work. Okay, so none of our options with this guy works, which means this is not how it factors. It must factor with 5n and 2n. So then we say, okay, well, then which one's going to work? Well, let's see. 5 times 3. And again, the fact that the positive numbers won't work because they're going to give us positive guys, right? That gives us a positive 31. Same thing over here. Positive, positive, it's not going to give us a negative. So we're going to start by looking at these negative guys. So 5 times negative 3 plus 2 times a negative 1. That's going to give us a negative 15 minus 2, which gives us our negative 17. That's what we wanted. So these are our values. These are our factors. So this will factor into 5n plus a negative 1 and 2n plus a negative 3, which will factor into 5n minus 1 times 2n minus 3. All right, that is our special factorizations and factoring where a is greater than 1, again, the best thing you can do for this section is practice over and over and over again. Come to the PowerPoint you have access to, do all of these examples that I didn't do with y'all together. I did notice that there are repeating questions in here and missed numbers, but try these guys. Go to the practice assignment, try everything on the practice assignment. Go to the book, try everything the book gives you. Practice a lot because that's how you're going to start to get to the point where you'll be able to see this guy as easily as you see this guy. All right, I'll see you in the next lecture video. Bye-bye.